All right. Good morning, everybody. Let's get started. My name is John Tekatala, and I am a program manager at Microsoft. And I work on Linux and UNIX in System Center and in Hyper-V. So a few years ago, this would not be happening. A session on Linux and UNIX at TechEd. You probably wouldn't have seen this. Well, this is not a joke. This is for real. Okay? Microsoft has developed and is providing to our customers some excellent solutions around Unix and Linux management. And this talk is about running and managing Linux and Unix in System Center and with Hyper-V. So with that, let's get started. So a little bit on the agenda. I'm going to talk about the Linux and Unix strategy in the private cloud. I've got a few slides on Linux integration services. These are the drivers that are used in Hyper-V. And then most of the talk is going to be around System Center and managing Linux and Unix with System Center. So we got the four managers over there. And I'm going to walk through these as part of my talk and interspace them with demos. So this is a level 200 presentation. And so I'm not going to go in depth on any one of these managers. What I'm going to do is actually talk from a Unix Linux perspective. So if you've been to other sessions on VMM or Config Manager or Operations Manager, those would have been maybe deep dives into each individual component. This talk is a horizontal slice. I'm going to look at these from a Linux perspective. So what are our goals? So Microsoft has embraced the fact that our customers use heterogeneous platforms. The world is heterogeneous. Our customers have heterogeneous environments. And we want to be able to support them. Sure, there are lots of Windows out there, Windows servers out there. But there's tons of Linux and Unix as well. And we want to provide our customers with a common interface, a single UI that they can use to manage everything, not just their Windows, but Unix and Linux as well. We want to make sure that Linux is a first-class citizen in the Microsoft private cloud. Okay. Towards that end, we've got some broad goals here. Offer robust Linux and Unix capabilities across Windows Server and System Center, as well as Azure. This talk is not about Azure, but mostly Windows Server and System Center. So we want to make sure that it is an integral part of our products. It's not something that we bolt on the side and sort of make work after the fact. We're thinking about how to integrate Linux into our products today as we talk, as we design stuff. We want to make sure it's production ready for our customers. So today, Ops Manager is deployed for Linux. About 25% of our customers are actually using Ops Manager. So just a show of hands, how many in the audience here are actually deploying any Linux, Unix capabilities across Windows Server System Center? Show of hands, please. OK, so that's about 50%. So you know, the rest of you, I think this talk is going to be interesting, so hang in there. I've got some good demos as well. So we want to also make sure there are no functional gaps between what we offer for Windows and what we offer for Linux and Unix. We need to be competitive in the Linux, Unix marketplace. We want to compete not just for your Linux and Unix, but we want to make sure that we've got a heterogeneous platform on which we can compete. We'd like to bring Microsoft simplicity, the interfaces that we have, our ability to make things simple for customers, and want to make sure that it's just high satisfaction. High sat is a must. It just has to work. And that's the kind of offering that we're looking to make that we've got for Windows, that we want to bring across for Linux and pull it all together. So here's the list of supported operating systems that we've got. And if you look at Operations Manager and Configuration Manager, the check marks go across the board. So under Linux, we've got 6 major OSs that we support: Red Hat, SUSE, CentOS, Ubuntu, Debian, and Oracle. And on the Unix side, we've got AIX, HPUX, as well as Solaris. Okay, we've got endpoint protection across the Linuxes. Virtual Machine Manager support is limited to what Hyper-V supports, and you've got the checkboxes there. And Azure's got support for some of the Linuxes. On the Unix side, for work in the cloud, we're not seeing a lot happen there, so we've got no plans in that space. We're not seeing anything happening in the public cloud or the private cloud as far as the Unixes goes. So let me talk about the Linux integration services that we've got. These are, like I said earlier, are the drivers that are used in Hyper-V. So they allow you to run Linuxes under Hyper-V, and the Linux guests essentially get the same kind of functionality that Windows guests have. It's competitive in functionality and performance to other Hyper-Vs. We want to make sure that when we run Linux under Hyper-V, we are going to compete against the other hypervisors that are out there. There's some good competition in the marketplace, and we want to ensure this. And the Linux integration services, the drivers we've got, help ensure that. So there's a lot of development that's happened and is ongoing. Some of the improvements have been VM bus updates. We've also worked on dynamic memory. So this is the ability to switch physical memory between the host and the guest, and to do that dynamically. As pressure increases on the guest, you want to be able to move memory from the host to the guest, and vice versa. One of the critical capabilities in ensuring that you can actually use your resources on the host effectively. The other area that we've done work on is a 2D synthetic video driver. In the past, if you looked at video of a Linux guest, you'd actually see a shadow or a ghost behind it. That's gone. It's now crisp and clear. So the cursor moves across without a shadow or a trail. Dynamic resizing of the VHDs, big major improvement. We want to make sure that we've enabled it such that when a VHD is increased in size, that is reflected in the guest as well. Okay? And there's more work that's ongoing. So one thing to keep in mind that the Linux integration services is asynchronous with major work that is done as part of Microsoft releases. Okay? And this next slide shows you how this all works. So in the past, this is what used to happen. Microsoft developers would develop the Linux integration services, post them on the Microsoft Download Center. Customers would download it, install it in their Linux instances, and that's how you were able to function. That's all changed now. The Microsoft developers are now part of the Linux community, and we make contributions just like other contributors to Linux. Our contributions are peer-reviewed and accepted by Linux, and once that happens, it goes into the Linux kernel. It becomes part of the Linux distro. That gets picked up by the different vendors. Okay? So essentially, that means that the Linux integration services for Hyper-V now are part and parcel of the Linux kernel, get picked up by the distro vendors, and get shipped as part of the major distros. Now, support issues would actually flow in the reverse direction. So if you've got a problem with Linux integration services for Hyper-V, you'd actually have to work backwards and with the distro vendors directly. So what does that net? What that means is most of the recent versions of our Linux integration services are built in and are shipped with the distro. And you've got the versions and LIS availability there. So as you can see, in Red Hat, for example, 5.9 and 6.4, it's built in and certified by Red Hat. SUSE 11 SP2, it's built in, and so on and so forth. Okay, support strategy is for vanilla questions. You want to contact the vendor. And if you've got issues running Linux under a hypervisor, feel free to contact either the vendor or Microsoft. All right, with that, I'm going to move on to System Center and talk about what's happening in that space. So these are the three major managers, if you want, in System Center. a virtual machine manager, configuration manager, and operations manager. So what are the capabilities that we support for Linux? We support personalization of the operating system instances. We support using service templates to deploy applications. We allow you to scale out, so one-to-many instances. We also facilitate live migration across Hyper-V hosts. So that's new functionality that's come in. On Config Manager, hardware inventory, inventory of software, the ability to create collections, the ability to distribute and install software, reporting, all that's supported. We also support endpoint protection under Configuration Manager. So what's going on in Operations Manager? What do we support? Monitoring the OS health and performance, monitoring log files, Java app servers, monitoring line of business apps, databases. Also, we also do audits of security events. So lots of good capabilities across these, and we're going to delve into them as in the next few slides. So my talk is going to be, focusing on the life cycle of a Linux instance. So we start by deploying it in Virtual Machine Manager, and then we will go and configure it through Config Manager and monitor it through Operations Manager. So my next few slides are going to be a combination of demos and presentations, and we'll try and walk through the life cycle, the full life cycle of a Linux instance. So what are the scenarios that we support with Virtual Machine Manager? Managing the private cloud with VMs. So just like you can manage the Windows instances, you can manage the Linux instances as well. You can deploy from a VM template and do specialization of the OS. You can use VM template as part of a service template and deploy multi-tiered applications. And I've got demos of this as we go through. So a little bit about OS specialization. The VHD image that you've got that does get deployed needs to have the VMM agent embedded and pre-installed. The hardware profile, we allow for MAC addresses to be obtained from a VMM managed pool. We also allow for your NIC, for your IP address, to be either from a DHCP or from a VMM managed pool. OS profile, we support configuring the host name, enabling a root password and SSH key, setting the time zone. And then the last one is really very interesting. It's a different capability, the run once command lines. This sort of lets you run a bunch of scripts, Linux scripts, after the deployment. So it allows you to customize your Linux instance using your own scripts. So with that, let's walk through a demo of this of the scenario. All right. So this is VMM. As you may notice, I've got, if I switch to VMM services, I've got a bunch of different Linux clients in here. Some of them are running, some of them in the stop state. But I've got Ubuntu, Red Hat, SLES, and a couple of Windows as well. So going back to library and looking at the VM templates, I've got a template here called my SLES developer template. And if I click on it, I am going to show you what we've got for hardware configuration. If you look at hardware configuration, this section looks very much like hardware configuration of Windows. You specify VHD, you specify processor, memory, you specify your ID devices, you've got the ability to specify your network capabilities. Okay, you can specify either a dynamic IP or a static IP from a pool. Okay, so the VM template from a hardware configuration perspective is very much like what you've got for Windows. Where we differentiate is really when it comes down to OS configuration. So I'm just going to walk through some of these. This is specifying the operating system, and in this case, I've got a bunch of different OSs that I can select from. This allows you to specify the computer name And the pound is very much like what you've got for Windows, where it would automatically increment, give it a number, and increment as you go through and deploy from this template. So here's the differentiator. This is being able to establish what the root credentials are. So the root user on a Linux instance, you can, like I said, specify it, or you can actually pull it from the run as account. Time zone is very much like what you've got for Windows. And here's the run once command that I talked about. So let me show you what I've got going here as part of this run once. The first thing I'm doing is creating a mount point with makedir. Then I'm mounting an NFS share. And then I'm running a script to install what is the configuration manager agent. Okay? So when this Linux instance gets started up, it's going to go ahead and use the NFS share to get the configuration manager install shell script and run the command to actually install the configuration manager from that share. Okay, so let's walk through this scenario, and I'm going to go through to App Controller. App Controller, as you may know, is a DevOps portal that allows you to launch and deploy instances. So I'm going to go and deploy to my Contoso cloud. I'm going to select a template here, and I'm going to select my SLES developer. I don't have limits set. This is from the DevOps portal, and I haven't set the limits in this case. Okay, I'm going to go ahead and configure the virtual machine. So I'm going to call it that should be my. Okay, computer name is Linux dev ###, and I'm going to select OK, and go ahead and do a deploy. Okay, with that, the deployment has started. So if I go back into my VMM screen and I look at what I've got here, I'm going to go to the Contoso cloud. And sure enough, you can see that my dev SLES is being in the create status, and it is being created. So I'll let that run in the background. And let's go back and do something else over here. Let's use a service template. So a service template, I've got an application now called Dinner Now Accounting. And I'm going to open that in the designer. And Dinner Now is a two-tier application. It's got a DB tier, a database tier, and a web tier. And if I look at the database tier, it is actually the OS is a SUSE Linux, and so is the web tier. It's also SUSE Linux. So let's look at the properties of this. What does this do? Notice that the host identifier is called @dbhostname. Okay, so the name has got it's actually a variable that we use. Okay, and I'll show you why we use this variable. If you look at run once, look at what it's doing. It's actually installing MySQL and the MySQL app for Dinner Now. Okay. So if you look at the web tier, again, this is a Linux instance. And if you look at the run once commands here, I am installing Apache, and I'm installing the Dinner Now app. But you'll notice that I'm specifying the @dbhost@ over here. This is the variable that I'd referred to earlier. So this allows me to tie my database tier with my web tier. So I'm going to go ahead and deploy config. And I'm just going to call it my Dinner Now. Okay, and it wants me to specify the name of the DB host. I'm going to call it Linux DB 007. just need to spell correctly. Refresh and deploy. I'm sure, yes, I'm sure. And with that, I've deployed a two-tier application. And if I go back and look at VMN services and look at what I've got going in the cloud, you can see that this has been deployed, and my DB tier and web tier are going on. The previous deployment is almost complete, so it's all happening. So we'll let this run in the background, and we'll move on to other areas, and we'll come back to this, as this progresses. All right, let's talk about OS specialization and how this actually happens. So we've got the VMM server and the VMM and the Hyper-V host. So the VMM server generates a Linux specialization doc. This is an XML file that's very much like the unattend.xml that you may be familiar with. The library server is where all the VHDs with Linux instances exist. And within each VHD is an agent. Okay? So the next thing that happens is that the VMM server creates an ISO with the specialization doc and an updated version of the Linux agent. So the library servers have got older versions of the Linux agent and newer versions of the agent that may come out. This method allows us to not have to recreate the library of VHDs every time there's a new instance of a new release of the VMM agent. Okay, so the new agent is now part of the ISO along with the specialization doc. Okay, the next thing that happens is that the host agent creates the VM using the library server and the VHD that was specified. Okay, it mounts the ISO in the virtual DVD drive and starts the VM. So as soon as the VM is started, the agent that's embedded in the VHD will check to see if there's a newer version of itself on the DVD. And if it is, it will exit and launch. It will launch the new version and exit itself. The newer version takes over, and then it reads the XML doc, the specialization doc, does the specialization, and shuts down and exits. At the end of it, the VMM agent is gone. After it does its job, the VMM agent is gone. All right, so let's talk about the VMM capabilities that work for Linux, live migration, including host-based pro tips, scaling out, from one to multiple instances. We support that. IP address management, we've talked about that. Storage management as well, and full scripting capabilities through PowerShell. So all the PowerShell capabilities that you've got, scripting capabilities to manage Windows VMs, also available for Linux VMs. All right, so we're walking through the life cycle, okay? So we've deployed, and now we're going to configure it. So we've got this end-to-end management of the Linux instance going on here. So let's talk about Config Manager. What are the features in Unix and Linux that we support? Okay, key capabilities: hardware inventory, inventory of software, software deployment, secure and authenticated communications, and integrated reporting. Some of the capabilities that we do not support. Okay, Config Manager has been around for a while. A lot of the capabilities are client-focused, not necessarily server-focused. There's some capabilities that we don't support, and I've got the list over there. A couple of them are ones that we think are important. For example, a desired configuration manager would be one. A lot of the others actually do not make sense for servers. So we're not going to support a lot of these. The internet-based client management, for example, it's really a scenario for somebody taking their laptop and working from Starbucks, for example, and being able to manage that. Not really applicable in server scenarios. All right, let's take a peek under the hood and look at the architecture of configuration management. Okay, we've got the agent that is the lower box, and we've got a client for Linux and Unix. And if you're familiar with Configuration Manager, you know that the client is called ccmexec.exe. We actually call the client in Unix and Linux ccmexec just to make it familiar. There's no WMI. Oh, the client actually talks to the CM server roles using native communication, so just like a Windows client would. There's no WMI in the Unix Linux world. So we've got OMI, which is Open Management Infrastructure. It is an open-sourced technology that Microsoft has made available. It is a standards-based SIM server, and it's got a model for pluggable providers. So the hardware inventory providers are pluggable, and they're the equivalent of WMI providers if you want. Okay, the providers access the platform abstraction layer, which then accesses the OS resources. So fairly similar to what you've got in Windows with a client and a SIM server with pluggable providers. So what are the scenarios that we support for hardware inventory? The ability to look at inventory through Resource Explorer. We've got the same, we've mapped the existing classes that Windows has to Linux Unix classes. So we're doing one-to-one mapping. So for example, if you take Win32 operating system, which is a Windows class, we've created a Linux class which is equivalent of that, and we've mapped the properties in Windows to equivalent Linux properties. So what that does is that when we send up hardware inventory, it goes into the same database tables along with Windows data. So when you do reporting, when you do other capabilities, it's all the same database. It's all consistent, and it's not a separate thing that we've got for Windows versus Unix and Linux. You can view installed software. This is the natively installed packages, programs, RPMs. You can create collections of computers based on these inventory properties, and you can run reports. So let's talk about software deployment. Obviously, deploying applications, deploying patches and updates. Deploying OS patches, you can do that as well. And you also have the ability to run arbitrary maintenance scripts. So the software deployment, the way that it works is that you've got a program and a package. So you can deploy this program package to a collection of computers. So if you do not specify a package, you've essentially got a program that you can have executed on a collection of Linux computers. And that is the equivalent of a maintenance script if you want. So let's talk about the implementation of software deployment. So this may be a familiar sight to you folks who know Configuration Manager. You've got the IT admin in front of the console, a site server, a management point, and a distribution point, and a bunch of Windows clients. All right, so what happens with software distribution? The IT admin creates a package. Typically, it's an MSI, and specifies the program, typically MSI exec. Okay, the IT admin then targets this package program to a collection of Windows computers. Okay, the agent on the Windows client wakes up periodically, polls the management point, downloads policy, determines what needs to happen, and based on that says, oh, I need to download a package from the distribution point. The distribution point can either be an SMB or an HTTP. It downloads the package, and then during the maintenance window, it does the deployment. Okay? So that's what happens on Windows. And at the end of it, a status message gets sent back so that the reports show up correctly and the status of the deployment shows up appropriately. So that's what happens in the Windows world. So into this mix, we're adding Linux and Unix servers. How does this all work? Guess what? The model is the same. Okay? You create a software distribution package. Instead of an MSI, it's a PKG or an RPM or tarball or whatever you want, whatever format you want. You specify the program. It could be a tar minus x minus x. It could be a RPM minus IV, whatever the appropriate command is. Okay? You target it to a collection of Linux computers. The agent on the Linux server, our agent, wakes up periodically, polls just like the Windows client does, downloads policy, determines that it needs to download a package, goes to the distribution point, downloads a package, and during the maintenance window, runs the package. Okay? And just like in Windows, the status message goes back. So what am I trying to convey here? What I'm trying to tell you is that the implementation dovetails with existing capabilities. Okay? So the IT admin uses the same console, the same UI. There's no different UI for Linux management. It's the same as the Windows UI. The hardware infrastructure, that hasn't changed. We're using existing hardware infrastructure. No need for additional site server roles. And most importantly is that the management paradigm that the IT admin is accustomed to, it remains the same. All right, let's do a quick demo of Configuration Manager. All right, so this is the CM console. I'm on the Devices tab, and I am going to, what you're seeing there are a bunch of different Linux and Unix servers that are registered with Configuration Manager. So you've got an HP UX, Red Hat SLES, CentOS, Sun, AIX. What I'm going to do at this point is do a refresh on this. And what you're seeing is a bunch of new computers have shown up here. Okay? So these were the guys that we launched through VMM. All right? And I am going to go ahead and approve these guys. Okay, so now they can download policy and start working hardware inventory and popping up hardware inventory and all that good stuff, right? So while that's happening, I've got an existing version or something that's already got hardware inventory, and I'm going to walk through that with you. Walk through the Resource Explorer and show you the kind of data that comes down. There's a ton of good information that pops up in here. I'm just going to walk through some of these classes and give you a feel for the data that shows up. You get to see disk drives. You get to see disk partitions. You get to see installed applications. These are all the RPMs that are on this SLES machine. You get to see logical disk information. And if I double-click on that, there's detailed information on free space and size. There's network adapter information. There's operating system information. I'm just going to walk through the OS information here. And free space available, physical memory, all that good stuff is available for you. Swap size. Processes would list all the running processes. Services would list the daemons that are running. So, a ton of good information here available to you. And now I'm just going to show you what we've got on an AIX machine as well. Very similar information, same set of classes. If you look at installed applications, you get to see all the LPPs that are installed. If you look at operating system, you get to see the version. It's AIX 7.1. It's, swap space is available. The version is 7.1, PowerPC, all that kind of information. All right, so I'm going to now switch to talk about device collections. So based on that hardware inventory, you can now create device collections. And I've got a collection of computers called All My SLES Computers. And this is a targeted collection that I'm going to target for software deployment. So if I go to software library, I can, what I do see is I've got a Java for SLES application. And I'm going to go ahead and show you what this has got. If I look at properties of this, you can see the data source. I went to the Java website and downloaded this version of Java, and it's on my Configuration Manager server. So it's on the /Java. That's the location of this Java RPM. And if you look at program, it's actually the command line, as you can see, is RPM minus IV, and the name of the RPM. If I look at requirements, you can actually target it to very specifically. And this is targeted at just at SLES 11, x86, x64 machines. All right, I'm going to go ahead and do a deployment of this. I'm going to target it at a collection of SLES computers, and I am going to click on Next. My distribution point has already been defined. Purpose is required. I'm going to say this is going to get installed immediately, and No user experience associated with our clients. There's no UI in the case of Unix and Linux, so nothing to do here. Distribution point, and click on Next and close. And with that, I've gone ahead and deployed Java to a collection of Linux computers. So let me now just look at what I've got on my Linux machine over here. So as you can see, I've got my two instances of my two processes running. ccmexec.bin is my client, and OMI is the SIM server. Those two guys are running, and I'm going to try and install Java on this machine. So if I do Java minus version, it tells me Java is not installed. So what I need to do, what needs to happen over here is that I need to wake up the client, get it to go and download policy and install Java on this machine. So in order to do that, I can't wait for the client to wake up and do its thing. I'm going to go ahead and force this to happen using a command called rs policy. So ccmexec minus rs policy will wake the client up and make it do the right thing here. All right, so while that's happening, I want to show you a couple of other things on this. Reporting works, like I said. So if you go and look at reports, you will see a comprehensive list of all your operating systems. So this is a count of all operating systems. So all the Linux and Unix operating systems show up here. Another interesting report that I like to show is the count of all instances of software that are registered. So if you're the person that's responsible for security, for example, and you want to know about the version of OpenSSL that's installed on all your Linux servers, all your SLES servers, you could use a report like this. And what this means is if I do a find on this, all right, the report is a little old. I want to just refresh it so it gets the latest data. Let's try this again. There we go. All right, so I'm going to look for OpenSSL in this collection, and you can see it's found OpenSSL 0.9.8 H is installed on 2 of the machines in this collection. If you had 200 machines that you were interested in, you could actually tell the number of machines that have got the latest version of OpenSSL. And if it does not have the latest version, then you can target the collection of computers that don't have the latest version with the latest version. So those are the kinds of things you can do. All right, let's go and see if Java has actually gotten deployed by now. So I've gone back and typed Java minus version, and sure enough, it is popped up with the right information. So while we were looking at the reports, we downloaded the package and ran the installation, and Java is now deployed on this instance. If I go back into look at status, I would actually see this update happening. So all the reporting back to the CM server works just like in Windows. All right, with that, I'm going to move to the next, to continue on the presentation. All right, so, yes, sir. So if it goes down, it will. There is no heartbeat on the configuration manager agent. So the question was, is there a heartbeat associated with the configuration manager agent? And the answer is no. There is no heartbeat associated with the configuration manager agent. All right, let's talk about monitoring. So what capabilities do we have in Operations Manager? We provide core health and performance monitoring. We give you diagnostics and recovery, so the ability to run a shell command. Just like in Windows, you can run a VB script and recover or get more information or recover from a situation. You can do the same thing. Okay, you can run a shell script and recover on your Linux client as well. We've got a bunch of templates to allow for custom monitoring and tasks, and I'm going to walk through that as part of my demo. We support reports. We support audit collection services. So if somebody is trying to get access to root account and doesn't have the credentials, you'd have an event in syslog-d, and we're monitoring that, and we'll let you know about it. We support centralized agent admin. So the UI is common. It basically centralizes the agent management using PowerShell. So let's look at the architecture of the OM agent. Okay. So in the past, we've got the Linux client, the Operations Manager Linux client, and it uses Pegasus SIM server with providers. Starting with R2, we're actually switching to the OMI SIM server. So this is the common SIM server that Config Manager has got. Operations Manager will have the same SIM server. And OMI is a larger initiative by Microsoft to make a common SIM server available to the community. And it's also going to be part of Windows. So this is a larger movement towards a common standards-based SIM server. Okay, we use an SSH connection in order to do agent maintenance. So the ability to start the agent, to update the agent, install the agent, those kind of things are supported through SSH. So if you do not want to use SSH, you can use your own methods to do this. So there are certain companies that prefer not to use SSH, and that's fine. You use your out-of-band methods to manage the Ops Managed client. Normal operations are conducted over WSMAN using HTTPS transport. So the health service will query, request, and get responses of data. You'll notice that the health service actually runs on the management server, and unlike on Windows, the smarts are actually living on the management server. So the health service will get raw data back. It would get whether or not the daemon is running, what the performance counter for a specific performance metric is. All that intelligence is on the OM server side. So the net is that the client is, the OM client is actually a very lightweight client, and it's just grabbing data and passing it back. Okay? So this is different from Windows, where the health service actually runs on the Windows client. Yes, sir. We support both. So the question was, do you support only password, or do you support a key? We support key-based as well. Okay, let's talk about the built-in monitoring that's available. We monitor CPU usage. We monitor, the amount of CPU time that's spent processing DPC, the amount of CPU time that's spent processing interrupts. We monitor memory usage and disk usage, inodes, network usage, processes, whether key processes are running or down. If they're down, you get a status message back. You generate an alert. Log files, the ability to actually look through log files and generate errors based on what's going on in certain log files. So a bunch of capabilities that are built in, and then there's a bunch of extension capabilities that we support. So some of the extension capabilities are custom log file monitoring. You can monitor pretty much any log file. You can specify a regular expression to use to search through the log file. And you can target a single computer or groups of computers. Service monitoring, you can specify the daemon that you want monitored and an alert that needs to be generated in case the daemon goes up or down. The ability to run command lines and generate your own rules and monitors. Very powerful capability. We support that as well. So we also have a bunch of partners that are putting together capabilities, shipping management packs. And you can see the list here. So there's management packs for Oracle and DB2, Apache. There's even one for AS400. So lots of capabilities that are coming in with a bunch of our partners. We also do Java app server monitoring. So as you can see, the top 4 Java app servers, Tomcat, JBoss, WebSphere, and WebLogic. We support them across Windows Server and across Linux. So all the Linux distros that we support are enabled for JE app server monitoring. We support the discovery, health, memory usage, monitoring garbage collection. So core health and performance metrics. We also allow you to use MBeans, for example, to monitor, to check for performance metrics. So performance counters and MBeans are enabled for monitoring. All right, so let's walk through a demo on Operations Manager. So let me bring up the screen here. All right, so this is sort of picking up from where we left off on the Virtual Machine Manager demo. And as you can see, all my database tier and web tier are up and running. And if all goes well, I should be able to run my application. The Dinner Now application is up and alive. So basically, what we started off with was a 2-tier app, database, and a web tier. And we've deployed it, and we've got the app running, and things are working. So let's switch to Operations Manager. Look at monitoring. Okay, so I've got something showing up here as critical. I'm just going to click on that. Oh, there's a few others that have just shown up. All right, so the Linux DB, the Linux web tier and database tier have actually shown up in here. So what we did have is we had an orchestrator script running in the background that was looking at what was in the cloud and populating OM so that we could actually discover this quickly. So that's why it's shown up so quickly here. All right, so let's see what we've got here. I'm looking at performance and health associated with this, and I've got a disk metric that is I'm looking at disk transfer per second. It's exceeded the threshold value, and we've got an alert that is generated. So it's complaining about that. Let's look at some of the other things that are available to us. So I'm just going to walk through some of the alerts, the performance metrics that are available, and some of the alerts that we can generate. Okay. So walking through some of the inbuilt. So these are the inbuilt capabilities that ship with OM. Okay. So the ability to look at performance as far as available memory is available swap space, total time spent on DPC, processor time spent on DPC, processor time spent on interrupts, and total processor time. So kind of the key operational parameters, we're monitoring the performance of these, and these come shipped as part and parcel of what's in box. Okay. Let's look at what we have under health. I'm just giving you a flavor of things. I'm not going to try and delve into everything. There's a lot in here. So I just want to give you a flavor. What I really want to do is move from this into some of the custom capabilities that we've got. So under health, we're looking at, we're monitoring, core processes, right? The ACPI process, the cron process, the KLog process, the SSH process, the syslog process, and UDAV. Okay, now these are what we're monitoring on a SLES box. If you went to an AIX or a Solaris machine, we'd have another set of processes that we're monitoring. So it's customized for the OS. Okay, now the next thing I want to do is show you some of the authoring capabilities that we've got. So out of the box, we're doing performance and health monitoring. We will generate alerts on operating system parameters. But what about apps, right? If you've got your own app that you want monitored, that you've deployed and you want monitored, how do you get that to happen? So let's walk through a scenario like that. So as you can see, I've got a process monitor for the Apache daemon. Let's create one for the MySQL daemon. Okay, so I'm going to click on Linux process monitoring, click next, and if I can spell. And I'm going to add this to the destination management pack. I'm going to add this to the Linux MySQL DB. Click on next, and let's select a process. Pick a computer here, and now I'm going to pick the server, and it's retrieving the processes. And here's my SQL daemon. I'm going to select that as the one I want to monitor. And what it's now done, it's pulled up the command line with all the command line parameters. Okay. Now I can choose, if I had multiple processes of the same name, then I want to be able to specify for example, if I've got multiple Java app instances running, okay, I want to be able to specify based on command line parameters. So I've got the ability to specify a regular expression to filter it down to a specific command line argument as well. But for in this case, I've got just one MySQL daemon running, and I'm going to go ahead with this. And I'm going to say generate an alert when the number of processes is less than 1. And go ahead and create. So with that, I've created a monitor that will generate an alert in case the MySQL daemon exits for any reason. Okay, this takes a couple, 3 seconds, and there it's done. All right, so that's all well and good. So if MySQL goes down, I will get an alert. But what about if the MySQL daemon runs into errors? It doesn't go down, but it just has a bunch of errors. I want to be able to check for that as well. So what I am going to do is now use one of our management pack objects and create a monitor, which is a unit monitor. And pick on scripting, generic. And I'm going to create a 2-state monitor. And I'm going to select the management pack to be the MySQL DB management pack that is going to get added to. And click on next. And this is going to give the name of MySQL error. And target monitor, I'm going to go with MySQL. Select the one that I did earlier. And click on next. And I can choose how frequently I want to run this. I'm just going to go with the default of every 15 minutes. And here's the interesting piece. I now get to specify a shell script or shell command that I can run to verify that MySQL has no errors. Okay. Now I've created a script that just does just that, and this is the script. So it runs MySQL. It with a parameter called -e show status. What this would do is spit out the list, the complete status, including errors. Now, if there is a word error in there, I'm looking for that. I'm running it in the batch mode. I'm piping standard error to standard out. And then I'm grabbing or searching for the word error. And I'm looking for the number of times this actually happens. Okay, WC is word count minus L, the number of lines. So this is very typical shell scripting that Linux admins use. They're very familiar with this. This is their environment, and they like to do this. So we've enabled this for them. Now, if I go and so let's see what happens if I actually run this shell script, just to give you an idea of. So here's the shell script, and I'm going to run this. Okay, without any errors, the number that comes back is 0. So 0 is no errors. I'm going to copy that and paste that as the command and click on next. And I now need to specify what the conditions are. So the error expression, if it is does not equal to, if it's not equal to 0, then we've got an error condition. And this is the healthy expression. If it is equal to 0, then we have good health. And with that, I've created a two-state monitor. I am going to click on next and say let's generate error alerts for this monitor, and go ahead and create. And that's pretty much how you can use shell scripting to create your own custom monitoring using the templates that we supply. So let me switch back to the rest of the presentation. I've got a slide on Data Protection Manager. So this is some capabilities that we support in DPM. There's new in R2. We are supporting online backups. So in the past, in order to back up, you had to suspend or stop the Linux VM. Starting with R2, you no longer need to do that. The backups that you do are file-consistent backups. So there are some limitations. You can't recover individual files. It's the entire file system. So, new capabilities in Data Protection Manager starting in R2. So, to summarize what we did, okay, what I was trying to get across in this presentation is there are lots of great capabilities for Unix and Linux management that Microsoft has. Some of it is not known to a lot of people. So the goal of my presentation was to make this information available to you, and also let you know that we're committed to doing this. It's not a couple of developers in a corner doing stuff. This is part of the strategy. We realize that our customers need this, and we are pursuing aggressively making sure that Linux management, Linux operation is part of the strategy. We want to make sure, we want to support the heterogeneous data center. And there's strong and expanding capabilities. We're moving forward with this. We've got teams in place, and people like myself and other program managers are actively working the area. And that was my talk, and thank you very much. Related content, some breakout sessions, hands-on labs. Not much time left. This is Friday, so appreciate your presence here, and thank you very much for attending. Yes, sir. So the question was preloaded appliances on CentOS for virtualization. Not supported at this point. Okay, something we should think about. Any other comments or questions? Yes, sir.
Agent on the Linux machines?
No, there isn't an agent on the Linux machines per se.
Okay, and is DPM able to run pre-scripts, post-scripts?
I don't believe so. I'll need to check and confirm that.
Something like this.
Yeah, I'm not sure exactly.
Maybe, for example, make a database save and.
Yeah, I don't believe that you've got extensive capabilities on doing that because DPM does not have the a running agent.
Okay, thanks.
We are now running Linux Red Hat on Hyper-V 2008 R2. And we are having some issues such losing network when we move the machines around the cluster, or sometimes even we are losing the operating system loses contact with the disk on the heavy loads. I wonder if you're aware of these issues or something specific to our installation, or you're aware that these issues happened on 2008 and they were hopefully solved on 2012.
Yeah, I will not be able to speak specifically to the issue at hand, but it's certainly something that you should pursue through support. The team is ready to take care of any issues that do show up. So if it does come up to the team, then we'll certainly take care of it. But I would recommend that you work through your support folks and have this looked at. I'm sorry, what was the question?
Would you recommend us to upgrade in terms of stability with Linux machines?
Absolutely. I would absolutely recommend that you get onto the latest versions because we've got more and more work that's gone in more recently. And performance-wise, you'll see big differences in 2012 moving forward.
Right now, we still have the necessity to run Linux on hardware. So, do you intend or have the idea to support bare metal deployment for Linux machines in the future with Config Manager?
So the question was running on
deploying Linux to hardware instead of only virtual.
I see. So it's OS deployment for Config Manager.
Right.
Okay. So that is something we looked at, and honestly, it's not very high on our list of priorities. A lot of the world is going virtual, and OS deployment on bare metal is not showing up as as critical as it used to be maybe 10 years ago. So not high on the priority list. There are other areas in Config Manager that are up on our priority list, and desired state configuration, for example, and patch management are areas that we definitely would like to see some work in that space, but not OSD, sorry. All right, I'll be around for some more time. Thank you very much.